Alright, hello everyone. Back again. So this is the second try. The first try we had some internet issue, so I have to delete that one and then we're gonna start again. So we are on to this house robber, and we have decided it's gonna be a dynamic programming, and we know, at least so far, what we think about is as we read through this array, we want to keep track of the maximum prize I can get for each position, and then when we reach a new position, what we're gonna do is we have two options. Option one, we rob this house. If we rob this house, then we cannot rob this one, but we can rob this one. So I'm basically gonna do this, the value of this plus the maximum prize I can get from this. So that's option one. Now option two is I do not rob this house. Right? If I do not rob this house, then I can rob this house. Right? It's not possible to think about it's not reasonable to think about robbing this, because if you rob this, you might as well rob this. Right? So if I do not rob this, then we have to rob this in order to. I shouldn't say rob this. Well, we have to visit this, check on this to get the maximum. So we just check on this, and eventually we're going to compare this plus this and this. Whichever one is larger will be the maximum price I can get for this position. And we just keep going down. So that was the idea. So we're going to make directory for December. Not December. Yeah, it's December. The December challenge. Right? December challenge. Time flies. Very soon, another year will be passed. Oh, what am I doing? That's not what I want. Nope, this is not what I want. I need to copy it first. Yeah, I'm gonna copy it first. So, December challenge. Then we do this. Wait. Nope. I forgot to change the folder name. That's the right way to go. Alright. And this DP, apparently, right? Apparently we can do it with O1 extra space. So that's what we're gonna do. O1 extra space. So basically what we need is a pre and a current. Well, I don't like to call it pre and a current. We're gonna call it PPMP, right? So PPMP will equals nums 0 and nums 1, right? And then for n in nums 2 to the n. Oh, and because length is 1 to 100, so we're going to say if len nums is smaller than 2, no, smaller than 3, so either 1 or 2, then we simply return the maximum nums. Otherwise, we do this, and we do this. Res equals max PPMP. That's what we start with, right? I can actually just say equals 1. Because it's 2, it's fine. Right? Equals 1. So which means it's only a 1, then we just return num 0. Otherwise, PPMP, res equals to this. And then we can say temp. What's temp? Temp is equal to maximum pp plus n and p, right? And we're gonna say res equals max res and temp, and pp and p equals, so p is equal to temp and pp is equal to p. Can we do this in one shot? Maybe we can. I mean, this one, I can put it here, right? So, nah, this is not right. This is not right. PP is here. P is here. So this one I say P will equal to this, right? And then PP will equal to P. And then we have a intermediate in between. So we do this first, so there's no temp, and we're just gonna say P. And at the end, we're gonna return res. Okay? Alright, we're gonna test. So that's the first test, 4. Second test is 12. Okay, so this is nums, rob, nums. Yeah, these two pass. I'm gonna try it. Oops! Well, wrong. Wrong answer. The hell? 2112. Answer should be 4. 2, 1 is 1, so it'll be 3. So 2, or maximum. Oh, P and PP. Oh, shoot. Yeah, that is correct. So PP is this. P is not nums 1. My god. P is the maximum of nums 0 and nums 1. And res equals P. There we go. Yeah, a little poo-poo here. In that case, I can actually say PP is 0, right? I can say PP is 0, and P is nums 1, nums 0, right? And then res is 0. So all of them can be defined in one line. And then for this is from 1, right? And then we do this. Yeah. So this is better, a little bit better. Can we do even better? I mean, now I'm only do this, so I don't even need this part, right? If I do only one value, it will return by itself as well. No, it does not. It bloody does not. All right, so nums 0 then, because that's what we start with, right? That's what we start with. Unless both of them are 0. Yeah, they all 0. They all start with 0. Huh? So this is the real one. Yep, that is the real one. So it's pretty standard, right? It's LeetCode. Hold on. So it's a standard DP. ON 32 70. Nothing more. Nothing more to say about this. But shall we take a look? No, we're not gonna take a look. We just take a look at the solutions we had last time. So it kind of give us an idea of what we tried a year and 2 months ago. Oh, I don't even need a arrest. I don't even need it. I just need a P because PP is equal to maximum this and this. Oh yeah, I don't even need a rest. P directly. Update. I don't even need a rest because each time I am computing the hold on, the maximum. Yeah, because the maximum will always be found at the end, right? Because you can always route more at the end, so you don't even need a separate rest. Because the reason we have a rest is we're afraid that some robbery happened in the, let's say, the left half of the array will have the value more than if accumulating to the right half. But this is not possible. If there's something large on the left side, then if we keep robbing, we're always going to get bigger, right? So, because each time, it's not each time, because the result, right, from robbing later houses will always achieve, because robbing later houses, right, will always achieve more value than robbing earlier houses. Therefore, that's all we need. And then we return P. Yep, that's all we need. Exact same thing. Okay, so that's that. I'll go back to the previous problem. It'll take like forever to load. Jeez. Now I'm gonna keep the journey. Let's keep the journey of working on the medium problem. I should have a timer just to see how long it takes to load. I'm pretty sure this is because the laptop is driving a screen, because the other day when I only have my laptop itself, no screen, it was fairly fast. Right? So the problem I think is just this laptop cannot drive two screens at the same time and also have the live stream software working at the same time. That's what I think. It doesn't matter. It's still loading. Okay. I think we are on to the fourth page. Stop working. Come on. All right. Yeah, having a terrible laptop teaches you how to be patient. You know? You gotta be patient. Right? Yeah, things don't always go your way. Things do not always go your way. All right, so we did additive numbers. How about this one? Additive numbers. Number 306. Maybe a math problem? Could be. Load and load and load. Still not done yet? My God, it's been like a minute. Alright, now we are. Additive number is a string whose digits can form additive sequence. A valid additive sequence should contain at least 3 numbers. Exactly. Except for the first 2 numbers, each subsequent number is a sequence. In the sequence must be the sum of the preceding 2. So this is Fibonacci number. Given a string containing only digits 0 to 9, write a function to determine if it's an additive number. Numbers in the additive sequence cannot have leading zeros. So sequence this and this is invalid. So 1, 1, 2, 3, 5, 8. 1, 9. Oh, we can have, oh, shoot. Oh. We can have 99. And 1 plus 9 is 100. And 100. Oh, 199. And I can have 100 or 199. It doesn't have to end at the third value. It could be just, then it could be anything. So 199. Oh, it has to be 100 and 199. Oh, no. What I'm thinking. 1 plus 99 is 100. And have 99 plus 100 that equals 199. So there are different ways to try, right? They never really say it's single digits or double digits or triple digits, right? They never really say that. And what we have, the length is 35, which means only 35 digits, and we can handle it. So basically, we say what, like DFS? Like I pick 1, right? And then the second character I can pick 9. Then I work, pick 99. And then work, and then we keep going. Okay, so I pick first digit, 1 digit value in the first one, and the second one I also pick 1 digit, and to see if it works, right? And if it doesn't work, our first one I'll pick 2 digits, right? First one I'll pick 2 digits, and then second one I'll pick 1 digit. Right? Okay, and what if I pick 3 digits? Alright, so every time I pick 1 digit, there's some caching. I think I can cache, right? So if I pick 1 digit already, so previously I pick 1 digit. Oh, hold on, because any digit I pick, right? If I pick a digit and the previous value, if the previous value is different, then my next result is also different. So I can have a previous value as well. So I can have a previous value and the current value. So if the previous value and the current position have seen before, then we can cache it. So we can cache it. Just we need 2 conditions for the cache. Okay, so now I have the previous value, and then I DFS, go to the next level with the previous value and the current position. And in the current position, I can just go 1, 2, 3, all the way down, right? However many I can, up until I cannot. Which I don't have to consider. I can consider as the edge case, the base case for the recursion. Basically, we just try to see if it ever works. We're gonna call a lot of int. Yes, we're gonna call a lot of int. And let's give it a shot. I mean, this method might work. Might. Not of. Hold on. So this one is 306. 306. Alrighty, come on. 306. So my idea is going to be from func tools import cache. I'm gonna cache it, right? So for this thing, def is it backtrack? It's not backtrack. It's DFS. So DFS. So it's gonna be pre. It's gonna be int and index int, and then this one will return. Oh, what do we need to return? True or false, right? So we only need to return true or false. So return Boolean value. And blah blah blah. And eventually, to call it, I think I just need to return DFS. Pre is gonna be 0, right? For the first value, it's gonna be 0. But actually, that's not true because there's no pre-value when I first get this, right? So this one can be anything. So no. So it should be return any, right? Any what? For I in range, let's say n. Let's put this n equals len nums. No, not len nums. It's a single value. In range this, right? So DFS int, right? Num I plus 1. So that is the previous value, I plus 1, and I plus 1. Right? So if I go the first digit, then this one will turn the first digit into an integer as the pre, and then the current digit will count as 1. Right? And if this one doesn't work, return a false, then we'll go I equals 1. Right? I equals 1, so we'll turn the first 2 digits, and then that's that. So any one of these works. Bravo. Now, looking at here, right? So, what are we doing? So we have an index, right? We have a pre. And we're basically going to say for, again, for, let's say for j in range from index to n, right? Current value is int num from j, no, from index to j plus 1. Right, so we have the current value. And we say if pre plus current hold on. Pre plus current. Hold a sec. So I give the range, so from here, so I pick 1, right? And I have 9. And then this one will get the first value out, get the 9 out. So the potential, right? So the potential shall be pre plus current, right? Pre plus current will be the potential value. Now we need to see from j plus 1 to some value that it fits this potential. How do I check that? How do I check that? Well, I check that by, I can turn potential into a string and I can zip it. So I can do, say, let's say if something, if all, right, then I do if all and dfs something, everything is true, now we return true. All right. Otherwise, try another one. So how does this one go? So we're gonna zip it. So we're gonna zip str pot, which is the potential value, and hold on. So let's do potstr equals to str this, right? And then that's the potential. Now, if the potential has more digits than the remaining, then it's not going to be possible. Now, how do we know that? Because the current is only getting bigger. So we say if len potential this is larger, right? More digits, right? More digits than the remaining. What is remaining? Remaining is n minus j plus 1, right? Because I am looking from index to j, so it's from j plus 1 all the way to the end. So it's going to be n minus 1 minus j plus 1 plus 1. So it's n minus this. If this is larger, then we simply break. We don't have to do it anymore. Otherwise, so the potential str will always be smaller than the remaining. So we're going to zip this and num from j plus 1 to the end, right? So I'm going to zip the 2 and it will cut off at the shortest. Then we're going to say for p and n in this, and we're going to say p equal to n, right? So if all of this is true, that means we did find a match. Then we keep DFS. So how do we keep DFS? Well, we keep DFS by the current value, right? The current value is an integer, so we have the current value and the index. What's the index? Index is the start of the next index. What is the start of the next index? The start of the next index is going to be j plus 1. All right, so the j plus 1 is going to be the next index. So the j plus 1, and if it's all true, return true. Otherwise, return false. Okay, let's try this. I have this shall be true. This shall be true as well. So num is number num. Fail. That is bad. That looks terrible. All right, let's try to figure out what went wrong. One at a time. Okay. Let's see. Let's print pre and index. Just see what happened. So I have 1 and 1. Go to 1, 2, go to 3, 2, 3, 2, 3. Where's 4? Where did 4 come from? Okay, that is trouble. Pre plus current, right? The current value and j plus 1. Oh no! Hold on. This is j plus 1. This is the index. My bad. So 1, 1, 2, 3, 5, and we go to 5, and we go to 8. We shall return true. There's no place to return true. That's why. So how do we return true? We say if index, which means we go to the next one, and then j plus 1. If index is equal to n, return true. Yep. Okay, try this. Did you cache it? I don't think you cached it. Okay. Let's see how fast. Let's see if we can pass. I also want to try a definitely wrong case, right? So like this case, it's definitely wrong, but it's worth trying. True, and I return true, but it's actually false. Wow. I just randomly type a value went in, and then it actually passed. No, that is not what we want. Okay, so what happened to the last one? Again. Print pre and index. Alright, let's see. Pre is 1 and index is 1. And pre is 2. Index is this. But nothing good. So pre become 1, 2. And the index is 2, no good. Pre 1, 2, 3, index 3, no good, and blah 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 blah, all the way to here, and the index. I see. How do we distinguish? That is the problem. We need to distinguish it. Well, the only way to this, because this one, we will go all the way. I mean, what we can do is instead of going range n, because we're going range n, the I will go to the last one. And if we go to the last one, and that's a moot point, because we require at least 3 numbers. We require at least 3 numbers. That's the thing, we require at least 3 numbers. If we require at least 3 numbers, I mean, what we can do is we can just pass an array and just keep track of the numbers. That might be easier to do, right? So let's say, I don't know, we're passing a number, right? The number will just be this. That's the previous number. In this case, and the previous number is already represented by this array. I don't need to pass the pre-number. All right, I can do this. Right? And then it's not pre. This is going to be nums. Right? We call it nums. That's going to be a list of integer. And then the check is if index equals to n and len nums is larger equal to 3, then return true. Otherwise, we try this and blah blah blah, and we return false. So the current is this. This is going to be nums minus 1, right, plus this. If this, return false. Otherwise, we're gonna blah blah blah, check, and DFS. How do we DFS? Well, what we can do is we say nums. Ooh. What we can do is actually append it here. Now we're gonna copy. I don't want to copy, right? I don't want to copy. So I'm gonna do this. If this, right? If all of them good, then I say nums.append current, and we say if this, and then return this. If not, then nums.pop. So what actually it's what should I call it? This is backtracking, and we have an error, unhashable. Oh shoot! Now it's unhashable because we have a list of values. Dang it! Now it's unhashable. But we do need it, right? We do need, because I need to know how many numbers, how many values have been accumulated. It's not hashable. The previous one is hashable, right? But the previous one I have issue because I don't know how many numbers. Well, definitely if we go all the way to the end, that's only one number, right? But I don't know how many numbers there are. It could be like ba and then that's it. Yeah, I do need to know how many numbers. So apparently I don't think this one needs to cache. I cannot cache. But I still have issues. What is this issue? Int is not sub. Yep. Well, it'll still work. I just say it will still work, but they do not work. Hold a sec. Hold a sec. What? How are you not working? They were working earlier. Nums minus 1, that's the previous one, right? Plus current, and nums.append current, and I'll pass it in, right? And if it's not, I will pop my current and then go back up. So I get a new current, right? Yeah? How did this go wrong? Print nums and index. One 5, right? 0, 1, 2, 3, 4, 5. Okay. So I hit into 5. So I come in. Index is 5. 0, 1, 2, 3, 4, 5. Index is 5. And then well, how did this one pass last time? I didn't change anything. Right, and then J, index of 5, and then 6. Right, so J is going to equal to 5. So 5 to 5, so current is 8. That gives us 13. and then we're gonna break, and then return false. I never reach here. Dude, come on, man. That is tricky. Isn't it just this? If I can reach, let me think about it. If I can reach 3 numbers, and that will be true. No, because we have remaining. No, I cannot reach 3 numbers. So, hold on. If I have the last value, right? So I handled this current value, and then we found j plus 1 to the end, and we found it, right? We found it, and we say I can append the current, and then we do this plus 1, and then we go to the next round. Okay, so the next round, all I need to know is if the next one, I already know what it is, right? I already know what it is. Hold. For all this and this, everything is the same. If they are the same, which means I do not check here. Well, in this case, I have a num_append current. Basically, we just need to say that, now I just say that the potential next value can be found as a substring. Oh, a substring. Isn't Python has substring? Yeah, I think Python has substring. Check substring in string. Right? That's what you're thinking. You check substring in string, and then so if substring in string, right? Can I just use in? I think so. Yeah, I can just use in. Yeah, we don't need find. Just say in. So all I need to do is if potential string in this, right? And then we're gonna do one more. We say if potential is equal to num j plus 1. Let's do this. If this equal to, then return true. Elif is in. We're gonna do this, and we're gonna ditch these things. Now we pass. Now everybody pass. Okay. So no LIO cache. Because we cannot cache it. All right, let's try this. Wrong answer. 1023. Oh, 1023. Oh, I think I know, because it cannot be leading. I think I have a leading 0. which means this one cancels 1, 1, 0, 1 doesn't work. 1, 0 doesn't work. Right? 1, 0, 2 doesn't work. Okay. Now I'm starting from here. 0, 2. Wait, 1 doesn't work. 0, 2 works. I cannot have leading zeros. I'll have to code that into the logic. There's no leading zeros here. Unless we start with a 0. That will be very unfortunate. Which I actually think they might. They might actually do this. 0, 0, 1, 1, 2. They might actually be very tricky to add that, so we have to strip. Yep, so I have to strip. Man, this is... So num is equal to... Wait, we're going to do L strip? 0, is that what it is? The hell? I can't even open the REPL. Oh my god. So 0, 0, 1, 1, 2, right? So what I think is a dot left strip. Say 0. Yep. So just say num dot left strip all the zeros, and then within the j in range this if, right, because we're going from index, so it's actually not j. We have to pass all the zeros for the index. So we say while num index is equal to 0. The 0, that's our starting point. Index plus equal 1. We skip all the zeros. So this is skip leading zeros. Something is not right. Stray index out of range. Huh? How? So while num index is equal to 0, and it's not equal to 0, why would it be out of range? Don't understand. It's out of range for this one. What the? Oh, because it hits this one first and then hit this one. Oh, easy then. Well, index is smaller than n and right. Test 0 pass, 1 pass, test 2 pass, and test 3 fail again. Result becomes true. That's interesting. So we get 1, right? And coming in, we're pointing to this, and we're skipping. Oh, we cannot even skip. Ah, so if we have a leading 0, then that's it. Then that's it. if it's a leading zero, then we just return false. Right? We say if this is this, we simply return false. Yeah, if there's any leading zero while we're doing it, we just return false. And we have to go the same thing. If index is smaller than n, and then we false. Right? Yes. That makes more sense. The leading zero. Any zero, like if I have any zero, that is not going to work. Okay? Try one more time. Wow. How slow can you be? Alright, let's try run this. It makes sense that there is no LL cache because the size is small. What the hell? How? I already stripped. I already stripped all the zeros. 00112. It shall be true. Oh, it shall be false. Oh, what was I doing? It shall be false. No, why do you strip the leading zeros? But does that mean if there's any leading zero, it's not going to be true? No, it could be. It could be. It just cannot have two. I can have one leading zero, but I cannot have two leading zeros. Ah, so in that case, I don't have to do this, right? If the first one is a zero, then the second one I'll return zero immediately, right? Because we have a zero. And then we have 0, 0. Oh, shoot. Now we have 0, 0. That is going to be an issue. Oh my god. Oh. And I just realized this is actually also not true. Because I can have 0 by itself. So something like this. 1, 0, 1, 0, 1. Yeah, this shall be true. But in the current setup, this one will be false. Yeah. Okay. Okay, so the tricky part is how to handle 0. No, this is not right. This is not right. I have to handle it inside, right? So what it means is if we have more than 2 digits, then the first digit cannot be 0. Okay. So let's handle it this way. And shouldn't you handle this one here as well? Yes. And actually, I just realized it's quite ridiculous. I can't just go DFS. I can everything just handle it. I can go DFS empty and 0, right? And then when I come inside, that's 0. So the current is 0 to, right? That's the current one. And potential, it's that we can say if nums, right? If nums, else just 0. Parenthesize it. So there's a potential string. So for the next one, well, it's actually no. Actually, no. It's not a potential string. There's no potential string. There is no potential string if we handle the first one. Dang it. That's true. There's no potential string. Because the first 2 is free. Right? The first 2 is free. Hold on. No. This is not right. But we do have to change how this, because I need to handle the 0 case. So we're going to say for I in range n, right? For I in range n. Now, what the trouble is going to be is because I cannot have 0, 0. I can have 0, which means 0, all 0 shall be, this is allowed, right? This is allowed, but 0, 0, 1, 1, 2, this is not allowed, because I can go 0, I cannot go 0, 0, right? Because that number will have a leading 0. So the value cannot have leading 0, so the 0 can only occur by itself. Therefore, if the second position, if we have more than one digit, if we have more than one digit and the first digit is 0, that is wrong. Okay, so here's the case. For I in this, right, and this one is go from 0 to I. We're going to say if I is larger than 0 and num 0 is equal to 0, right? So that means we have more than one digit value and the first digit is 0. And this one is going to be continue. Well, actually, it's going to be break. We're going to return false here, right? Yeah, because the first digit is 0, and if it's not treated by itself, and then it can return 0. So if this, return on break. Otherwise, right? Otherwise, then we're going to say if DFS, copy the whole thing. Right? If DFS is true, return true. Otherwise, try it again, right? Try it again. So that's the end, and we have to handle this case inside here as well, right? So for j in this, we say if j is larger than index, right? J is larger than index, and num index is equal to 0. That's the case. Then we're gonna say that's gonna return false immediately, right? I'm gonna return false immediately. So with this change, everything passes. So the tricky part is handling this stupid 0 thing, right? I'll run this, everything will pass. Submit again. Oh, there's actually a lot more edge cases than I initially thought. There you go. Now this one's correct. So yeah, I won't say this one's like particularly difficult. Now this one, 306, right? Now this one is not particularly difficult, but it does involve, it does have its tricky portion, right? Tricky portion. The general idea is in DFS with backtracking, right? It's a general idea. The tricky part is to handle the case where any number with leading zeros, with leading 0 is not allowed, but the number 0 itself is allowed. This means, right? This means 0, 0, 0, 0 is valid, right? But 0, 0, 1, 2, 1, 1, 2 is not. Oh my god, what's the runtime on this? They're huge. The runtime, I think, is huge. Or say, I don't know. Shouldn't that be 2 to the something power? Because I checked the first one, I checked the second one. Let me think. So check the remaining and hold a sec. In this case, do we need no, we do not. I never check the length. Right? I never check the length. So it's like a current potential. Yeah, I don't have to. Oh, then I can cache it. Then I can cache it. It is this. Then I can cache it. I don't need to have nums. It's a pre. It's a never use, right? Current. This is just gonna be pre. Right? And then this is fine. This is fine. This is fine. Then we don't have to do even this. We just do current. No popping. It still passed, right? So in this case, I can cache. Oh, it'll take longer, but it's fine. We don't have to. Yeah, we can cache it. If this is this, we break. If it's simple, we're gonna do this. And actually, we don't know. There's 3 if statements, right? 3 if statements. I can actually do this. The main rem str equals num j plus 1. And then we just use len rem str, right? And then this and this can both be replaced by rem str. Yeah. Save a copy. Oh, that is actually not true, right? That is actually not true. I just realized this. Hold on. What I'm saying is 1, 2, if I have, like, say 4, 3, right? And I have 1 and 2, and I said the potential is 3, and then remnant is going to be 4, 3, and potential is not larger than, not equal to, potential is in this, right? Potential is in it, but it has to start. No, this is not right. Although, I think if I do this, it's still going to return false, because 1, 2, I would go, current is 2, and I will go j plus 1, probably this, and then we're coming in, and yeah, it might still be wrong, but this is not right. I think we have to zip it, because it has to be start, right? It has to start, so I think I shall still zip it. Rem str, right? And we can just say if all p equals r for pr in oh, holy guacamole, no, I have wrong. What? Hold on. Oh, this shall be false. One zero one zero one. Wait, is this true or false? That shall be false. Yeah. That shall be false, and this pass. Ah, we find a weak test case. Yeah, this is supposed to be false. All right, so we need to write it up. All right, so this one, general idea is DFS. The tricky part is to handle the case where there are any zero, and actually it's more. Okay, so for this, because we cached, right? Because we cached, it depends on how many different pre we have. I still don't know the runtime. It's gonna be complicated. You say each index is visit once. Okay, if I say each index is visit each index and the pre, how many different types of pre do we have for each index? Well, for each index, the pre is going to be this, 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 this. So we're going to have n different indices. Well, for each index, the pre can be 1, 2, 3, and like for index I have I minus 1 different type, right? So it's I minus 1. So I times, so it's O(n) squared. This is actually O(n) squared. We find out that, so this is the correct answer. I think this is the correct answer. Yes, this is the correct answer. But the other one, which we changed this, so this is incorrect. Right? So this is incorrect. Incorrect. But OJ, but passes OJ. But passes OJ. So incorrect is if this is in, right? It will wrong here, but it will pass OJ. But it passes OJ. Yep, so that is the issue. And I just realized these two can be combined. And oh, and these three can be combined. Or say if this or this. Yep. Okay. How do I report? Maybe somebody has reported already. Let's check. Oh, we first check to see what are the smart solutions. Oh, it's actually more than O(n) squared because this part takes time as well. So it could be more than O(n) squared. So I think it's actually O(n) tripled. recursive. Must be some simple solution. Oh, I was going to say simple solution. Alright. First and second sequence, check if the rest string match them somewhat recursively. The range, the length of their sum should be largely equal to max. We generate the first two. Okay, so I add 1 to the end. J equal to this. Big integer again is valid. Then if true, and is valid. So we generate the first two integers. Hold on, so we generate all different types of first two integers. So once we generate the first two integers, the remaining can be compared easily. I think that's what it says. Yes, the first integer, the second integer we generate. Now we can check is valid. So if it's valid, we have the two integers. So two integers, we have a start, right? And if start equals this, that means we're good. Otherwise, x2 equals x2 dot add x1. x1 equals x2 subtract x1. String sum equals x2 to this. So number starts with. Oh, that's a much simpler solution. Starts with. Yes, we don't have to do this. It starts with. Python has it as well. Python has as well. So I think it's rem this dot start with. It has start with, right? A dot start. Yeah, starts with 0, 1. It was false. So starts with potential str. There we go. That's it. And the other one is this one in rem str. Okay. All right, this is better. I like this one better. Let's try it. Yeah, it is more straightforward this way. So 2, question 1, right? So this is from the easier recursion. Reference. All right, let's try to write it ourselves. So this means we're going to have 2 values. I'm going to check if it's valid. So def is valid. We have pre. Actually, do we need pre? So we have this. We have this. We're doing the new one, the current one. Yeah, pre and current. Pre-current, and we have an index. Right. One in return boolean value. Find all combinations, all possible pairs of the first two numbers, and run the check for the remaining. So is valid. I have a pre and a current, and I have an index. So I'm going to first check the current and say if num index, right, towards the end, that starts with str current. If that's true, then we can move on, right? Then we say is valid current pre plus current, right? And then and then what? Then index plus len str current, right? Len str current. If it's this, there's 3. There's 1, 2. There's 3 length. There's 0. So 1, 2, 3. Yes. So we're gonna do this. We're gonna say if return true, right? Well, and then return false. Okay. So eventually, we're gonna hit index is equal to n. Right? If index equal to n, return true. Right? Yeah. And we need n equals len. N equals len num. Of course, we haven't considered the leading 0 issue, right? So we need to also consider leading 0 issue. So how do we consider leading 0 issue? Well, we have the current, right, and the index. Current and the index. Now, if that starts with and then this will and then this can solve using start with can solve this problem, because I'm saying number dot start with current, right? So basically saying A is this. A dot starts with a number 1, right? This will return false. Oh wait, hold on. This will return false. So that's how you handle the leading 0 issue, because this is the one that will have leading zeros, and this will be but still we have a 0, 0. Oh shoot. Index, right? Index going all the way down. That's the entire thing. That start with current. That will be a single value. Yes, this one will never have leading 0, right? So yes, I think this is actually true. Okay, so that is valid. It's true. Or not if this. So they can. Shouldn't we just say return this or this or this and is valid? All right. Then what? Then we need to prepare the 2 numbers. So how do we prepare the 2 numbers? Well, we can prepare like this. For I in range, that's true, we can go all the way to range n divided by 2, because actually n divided by 2. What if I have a 5, right? A 3 digit. N divided by 2 is 1. So I can only go 0. Which is true, you cannot go higher, right? It cannot go higher. So what if it's 4 values? N divided by 2 is 2. So 0, 1. Yeah. So for I in this, right? And then can say if I larger than 0 and num 0 is equal to 0, right? That we're gonna break because this one will return false. Else, I'm gonna say for j in range, so I, right? So j has to be I plus 1 to the end. Right? J is in the I plus 1. Oh, not to the end. Okay, to the end is not going to work. Because to the end is not going to work. Because if it's to the end, and everybody will be true. If this one comes in, index will be n. So it has to go through this part first. So I cannot go all the way. So I have to go n minus 1. Right? I cannot go to the end. Okay, now we have the two values. So we're going to say if is valid, what is pre? Well, pre, there's no pre. The pre is not I. The pre is to a certain extent. So pre is equal to int, right, num, all the way to I plus 1. Current was int num I plus 1 all the way to j plus 1, right? So it's valid. The pre is actually current, and the current is actually pre plus current. Yeah, I like to do it this way. Now it's not as readable. This is more readable. And index. What can the index be? J plus 1, that's in the index. So if this, then we'll return true. Right? Else why we'll just keep going until it returns false. So that's solution 2. Try it. We have bad things going on. So number 3 and number 4. So 0, 1, 2. 0, 1, 2. Number 3, number 4. Return true. How? Let's print pre-current index. How about that? The pre. How is pre 0? Yes, pre is 0. Current is 1. So we want to index 2. And it's not, so it's false. Now pre is equal to 2. Oh, I think the same thing shall apply here as well. So if j is larger than I, and num's I is equal to 0, right? Because j is starting from I plus 1. Hold on, j starts from I plus 1, right? To the end. So actually j is larger than I plus 1, and num's I plus 1 is 0. Then we break. Then this one passes. Okay, understandable. Yeah, so the handling of the leading 0 is happening here. Now everything passed. Okay, got the submission. Yeah, this is much easier. Much easier. Oh, I think it died on me. Come on. The other one I think has died on me. I'll turn it off.